So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over some past GCSE Maths higher exam questions based around the big mark questions. Now as always there'll be a copy of the questions that we go through in this video available for you to download and have an attempt at, which I strongly recommend you do so you can test your prior knowledge and see what your first attempt at these questions would be like compared to the real answers. Now before we get started working through these past exam questions, it's worth mentioning that I strongly would not recommend going through these questions unless you're fully confident in each of the topics that are shown on the screen. Now that's reason for that is because with these big mark questions you may find that the question might not be specific to one particular topic, it may include different topics. All I've done here is just try to look at the question and just write down what topic screams that to me when reading the question out, but it may involve different skills from other topics. So I personally would only tackle these particular questions once you've covered the curriculum and you've covered all the topics that you're supposed to, and you really want to test your knowledge at an elite level. So looking at the questions that we're going to cover in this video, so we're going to take a look at a question from fractions, from Venn diagrams, indices, brackets simplifying, coordinate geometry, and ratio and fractions. Now, although there's no formal indication about where these questions have taken from a calculator or a non-calculator paper, I personally would always assume that a question is non-calculator, simply because that not all questions on a calculator paper involve calculators. So if you can try and answer a question without a calculator, that's going to be a great skill for you to develop. But obviously if it then turns up on a calculator paper, you've got the comfort of being able to use a calculator. Now again, before we start working through these questions, a little reminder that if you're wanting access to these questions, all you need to do is simply click on the link in the description. And along there, you'll also find the actual official mark scheme where there may be different ways of getting the answer that I'm going to go through. However, I'm going to go the answer that kind of makes more sense to me. So looking at question 1, it says work out 7/10 minus 4/15 divided by 2/3, and it says give your answer as a fraction. Now again, if this is on a calculator paper, it'd be worth like literally 2 marks simply because I just need to type into my calculator, press equals, and I get the answer. So this one definitely most likely going to be on a non-calculator paper. Now with this particular question, what we want to do is look at BIDMAS, and we want to do the brackets first. Now inside the bracket we're taking away fractions, so when we're thinking about taking away fractions you always want to think about a common denominator. Now before we do that, what you want to do is just have a quick check to make sure you can't simplify the individual fractions, because obviously working with smaller numbers is going to be a lot easier than working with bigger numbers. So we can't simplify 7/10 and I can't simplify 4/15, so I just go straight into getting my common denominator. Now in this case my common denominator, or the shortest common multiple of 10 and 15, is going to be 30. So if I multiply this fraction by 3 and this fraction by 2, I'm going to get 21 over 30 minus, and it's going to be 8 over 30. And again, I'm not going to forget the divided by 2/3, so I'm still going to write that down because I do not want to forget that. So then simplifying this fraction, the bracket, I get 21 take away 8, which is going to give me 13 over 30, and then I can then work with the division. Now when dividing fractions we flip the second fraction and it turns into a multiply. So then all I then need to do is do 13 times 3, which is 39, and 30 times 2, which is 60. Then what I then want to do is then simplify this fraction if possible. Now I can simplify this fraction because I divide both numbers by 3, so I've got 13 and 60 divided by 3 is 20. So my final answer is going to be 13 over 20. Moving on to question 2, it says here is some information about 120 people who visit a shop. 3/4 of people buy neither a coat nor a dress. 19 people buy a coat, 14 people buy a dress, and it says complete the Venn diagram to represent the information, and we've got the letters and show you what they represent. So in this particular question what we know is that there are 120 people included in this particular sample. So of the 4 numbers, all of those numbers that I write need to add up to 120. Let me just zoom out so we can see the information and the Venn diagram. Now looking at the first bit of information, now more often than not the information that's given to you in the question is usually what's going to be used first, second, and etc. So here we know that 3/4 of the people buy neither a coat or a dress. So this is going to be our outside number, which is this number here. So then if we then work out 3/4 of 120, so 120 divided by 4 is 30, times 3 is going to give me 90. So this number here is going to be 90. Now it also says that 19 people buy a coat, 14 people buy a dress. Now typically when you're completing a Venn diagram, you always want to start in the middle. Now we don't know what the number of people who own a coat and a dress are. So what I'm going to do here is I'm just going to label that A. And we'll label this section B and this section C. So from this bit of information here, the coat, which is represented by the circle C, so I know that A plus B equals 19. And I also know from the other bit of information here for the dress that A plus C equals 14. Now the other bit of information that I know is if I want to work out the total number of all of these, so here I'm going to have got A plus B plus C is going to equal the total number, which is 120, minus the outside number, which is 90. So if I simplify that, I get A plus B plus C equals 30. Now what I'm now going to do is use these bits of information to now work out what the answer is going to be. So I'm just going to put a little box around these bits of key information here, like so. Now using this information here and this information here, well, I know that AB plus C equals 30, but I know that A plus B equals 19, so I know that 19 plus C equals 30. So then I can then work out what C is, which is going to be 11. So I can write 11 there. Then now that I know what that C equals 11, I can take this bit of information here and I know that A plus C equals 14. Well, if C equals 11, I know that A is going to equal 3. And then from this, because I know A plus B plus C equals 30, and I know the values of A and C now, so A plus B plus C equals 30. A is 3 plus B, which I don't know. C I know is 11 equals 30. So then I've got 14, so B equals 16. And there is my completed Venn diagram. Now moving on to question 3, it says write 3 to the power 6 multiplied by 3 to the power 5 to 3 to the power 7 in the form of n to 1, where n is an integer. Now for this, what we need to do is simplify the brackets. So here we've got the base numbers are the same because we've got a base of 3 in both of these. Let me just zoom in so we can see a little bit clearer on the screen, and it's nicely reset. So let's just go to that question there. So here we've got 3 to the power 6 multiplied by 3 to the power 5. So what do we do when we're multiplying? We add the powers. So that's going to be 3 to the power of 11 to 3 to the power of 7. Now for this you may think, well, do we just take away the powers? But that's not going to be the case, because what we need to do is now compare this to this ratio in which we want to try and get 1 as our second part. So for this, to get 1, I'm going to divide both of these ratios by 3 to the power of 7. Which then leaves me, when I'm dividing, I take away the powers. So that then becomes 3 to the power of 4 to 1. Now 3 to the power of 4 is 81. So it's going to be 81 to 1. So the value of n is 81. Now moving on to question 4, it's asking us to show that the expansion and simplification of this algebraic expression simplifies to become an integer. So for this, all we need to do is just be mindful of the 3 sections of expanding the brackets. So if we expand the first set of brackets, which is the double brackets, we get 6x squared minus 15x plus 8x minus 20. Then if we look at the second set of brackets, we get a minus 11x squared plus 22x. And then if we multiply out the third set of brackets, we get positive 5x squared minus 15x minus 5. And then all that's left for us to do is to collect all the like terms together. So here we've got 6x squared minus 11x squared plus 5x squared gives me 0x squared. And then if I look at the x's, I've got minus 15 plus 8 plus 22 minus 15x, which gives me 0x, and then finally minus 20 minus 5 gives me minus 25, leaving me with just minus 25, which is our integer, and there we go. Moving on to question 5, it says the graph has the equation of y equals x squared plus px plus r, where p and r are constants. The graph passes through the points of 0, 4, 1, 3 and 8w, and the question is asking us to find the value of w. Now for this particular question, what we need to do first is we need to use 0, 4 and 1, 3 to find p and r. So that's the first thing we need to do. Now how do we do that? Well, we do that by substituting these coordinates into the equation. So here using 0, 4, so using this we've got x equals 0 and y equals 4. So if I substitute that in, I'm going to end up with 4 equals 0 squared plus 0 times p plus r, which leaves me with an r value of 4. Let me just put a little bubble around that. Then if I use x equals 1 and y equals 3 and substitute that in, I get 3 equals, and it's going to give me 1 squared plus 1p plus r equals, and that one, that's not going to equals anything, so I already know it equals 3. Then simplifying all of that, I get 3 equals 1, don't know why I've put a plus there, let me just get rid of that, equals 1. I know that r equals 4, so it's going to be 1p plus 4. So then from this, taking away the 5 to the 3, I get minus 2 equals p, and there is my value of p. So what that then becomes, if I join these two things together, that then becomes, actually let me just do that again. So combining these two things, we get y equals x squared, and we know that p equals minus 2, so it's minus 2x plus 4. So this is our equation. Now once I know the equation, I can now find out what w is. So here using 8w, well, I know that this is my x value, this is my y value, so I've got w equals 8 squared minus 2 lots of 8 plus 4, so w equals 64 minus 16 plus 4. So that's going to give me w equals 64 minus 12, and 64 minus 12 gives me an answer of 52. So moving on to our last question, it says that a road has 3 sections, D, E and F. The lengths of D and E are in the ratios of D to E is 3 to 5 and E to F is 7 to 4. What fraction of the length of the road is section D? So first things first, let's start by writing down the 3 ratios, which are all connected as they are on a road. So here we know that using this bit of information here, we know D to E is 3 to 5. And using this bit of information, we know that E to F is in the ratio of 7 to 4. Now what we want to try and do is get the ratios of E the same value. Now thinking of a common multiple of 5 and 7, that's going to be 35. So what have I done there? Well, I've multiplied this fraction by 7. I'm going to multiply this fraction by 5 to find the relative parts of D and F. So here 3 times 7 is 21 and 4 times 5 is 20. So then from this, what I can then do is then work out the total number of parts. So it's going to be 21 plus 35 plus 20, which is going to give me a total of 76. So then the fraction of D is going to be the parts, which is 21 over 76. Can that be simplified? No, it can't. So there is my final answer.